Hello everyone, today I'm going to talk about the Buffon's needle experiment. So here we have with 5 vertical lines that are equidistant to each other. In this case it's 5 lines, but you can also try any other amount of lines. The more the better. And then we have some needles. As shown here, the needles have the same length, and the distance between every vertical line is 2 needles long, as shown here. And then we're going to randomly drop these needles onto this vertical grid, like randomly with no preferences, like this. And then we're going to count how many needles we dropped in total. So after this, we're going to count how much of these needles cross the line. For example, this crosses the line, this also, and also this. So we count how much of them crosses the line. And then divide the first number by the second number. So we have like the total number of needles divided by the number of needles that cross the line. Or after counting, this equals 41 divided by 13. So when you plug this onto a calculator, you will find that this value equals 3.153846 blah blah blah. Well, this surprisingly you may find out this will be really close to pi. Well, Buffon's needle experiment is a way to compute the decimals of pi, since when you do an infinite amount of needles, it actually becomes pi. So I have a really simple and concise proof why it outputs pi that only requires very simple calculations on only the fundamentals of calculus. So here we have our proof. Now we have 2 vertical lines shown here as a small section of the grid, and this is our needle, and we're going to project this needle onto a line that is perpendicular to the vertical lines, as shown here. And after the needle is being projected, we have this part, and then we can make an angle theta, and we can make a triangle. So if we say that the length of the needle is 1, then this will be 2, and the base of the triangle will be, by trigonometry, cosine theta. So there we have, let's say we want to compute the probability that the needle crosses the line. Well, that equals the average probability that the projection crosses the line. Well, there's many projections, so we need to find the average. Well, that equals the probability of the average projection crossing the line. Now we need to find the average projection, but we have another little simple trick here. So we're going to draw a graph, specifically y equals cosine x, and this point is equal to pi over 2. So actually these vertical lines shown here are all the lengths of the projections, and when they add together they form this graph. And here we have this section of the graph, and all the vertical lines are the projection lengths, and this part is pi over 2. And then we're going to make a rectangle that has the same area as the first graph, and we're going to make the base to be equal to pi divided by 2. And by using calculus, we can find that the curve under y equals cosine x from 0 to pi over 2 is equal to 1. So the area of this rectangle is 1. And using some simple calculations, we can find that this side is equal to 2 divided by pi. Now we've found the average projection length. Now we need to do something that figures out the probability. Now, the projection is in 1 dimension. So here are all different possibilities for the projection, and we're going to specify a reference point. We're going to make it to be the point that is the rightmost to the projection, like this. And when the reference point is in this area, the projection will cross the line, and that the length of this region is 2 divided by pi. And when the point is in this region, it won't. And of course, this is 2, and so this will be 2 minus 2 divided by pi. So although we're not computing the probability here, the value that we found to be really close to 2 pi is actually the amount of needles we tossed in total divided by the amount of needles that crossed the line. But think about probability is a really good way. So we have the total number of needles tosses and the number of needles that cross the line. So this equals, we can think of this as regional probability. So this equals the length of the region between the line and the length of the region where the needle crosses the line. And as you can see in the left picture, this is equal to 2 divided by pi. So this of course equals pi. And there we have it with our answer. This solution does not require any complicated calculations and only needs the fundamentals of calculus. So everyone, thanks for watching, and don't forget to like this video and subscribe. And I'll see you next time.